So here let's start with our new topic, triple DES, right? So already in last class, 2 3 classes we have seen DES algorithm, right? How we are encrypting the data by using that algorithm. Okay, so in that one, main things are that input data, right, is required to which you want to encrypt. Then in how many rounds you are taking, what will be the key size, right, and how you are processing the data. How you are processing the data means we have divided the data into the two halls, right? Original input size is 64-bit, but it got divided into two halls, 32-bit and 32-bit. Okay, then we are processing that data. Okay, so as the time goes, so that thing was, we have seen that in 1975, right, like that, but okay, or in, we can say that in 1970s they have implemented that algorithm. So at the by that time it looks good, right? Means what, less computational devices was there, and that things. But at slowly that computational devices is got improved, right? So that key size is there, we have taken, is key size there we have taken as a 56-bit only, 50 56-bit key we have taken. Okay, so 56-bit key at one state it become, right, for this highly computational resources or highly data processing systems, this is 56-bit key became very small, right? Now they are in that they are feeling that less security. So right now they want to replace that algorithm, right? But this algorithm is very much liked by this by that banking applications or financial transactions, right? And they don't want to lose, or they don't want any replacement for this DES algorithm, right? They want any some modifications in the DES only. Okay, am I audible?
Yes, sir.
Okay, so here what I was telling, that this we have seen this DES algorithm, right? This DES algorithm, first we have right started that use of the DES algorithm once. So for all that banking purpose or right financial transaction purpose, right, they like DES very much, right? They like DES very much. They don't want to lose the DES. Only they want some options to modify this DES. Only one options they want to, right, some improvement in the DES, right? So what they did that in 1985, up to 1985, right? Or you can say that just before that 1985, first implementation was there in 1985, but work is started before that 1985 only. Okay, so what they did that uh, uh, either you don't want to lose this DES algorithm, right, or you want that some modification in that DES itself. So what they did is that, why can't we repeat this DES algorithm 3 times, right? Why we cannot why we can't right uh, use this DES algorithm 3 times to for the encryption of that data, right? So when you use this DES 3 times, automatically the key size will get increased, right? So here we have taken the key sizes in DES algorithm 56-bit. 56-bit key we have taken, uh, in DES algorithm. So here in triple DES, right? Suppose we are repeating the DES algorithm three times, right? So key also will get repeated, right? 56, 56, 56 bits. It will become as an 168 bit. It will become as an 168 bit key will become, right? That means we can say that security will get increased. 168 bit key means, right, there is a significant improvement in the security bit of this algorithm, right? So one side you are telling that DES is insufficient now, right? DES is providing that less security now. Why? What is the reason for that? One means DES key is key size is 56 bit key, right? 56 bit keyword. So here I will show you that one table what happens if this key is less bit, right? So what they are telling that if key is less, easily we can break that code bit, easily we can break that code. So what they want some improvement in, right, key size bit. Why can't you produce some large size key bit, right? So why that large size key means there is an high computational devices are available in the market which can easily break your key weight. So here you can see that disk key length is 56 bit key weight, right? And block size is 64 bit key bit, and possible keys with this 56 bit is 2 power 56 bit that we can break in 400 days bit, that we can break in 400 days, right? So so means you forget about that number of days, right? But right, in other words, how I can say is there is a possibility that we can break it, there is a possibility that we can break the key bit, but we want one algorithm, right? That key we cannot break, that key we cannot break either, or it should take the years of time, but years of time, but not a days of time, right? 400 days means almost suppose 1 year, but right? So so we want improvements in the key size so that no one should uh, break your code bit. Okay, so that's why they have introduced the triple DES bit. So, right, means that DES algorithms we are repeating the three times. DES algorithm we are repeating that three times. Okay, so three times we are repeating means key size also will get multiplied by 3. So earlier key size is 56 bit, right? If you multiply with 3, then you will get the key size as 168 bit, key size is 168 bit, right? So here triple DES means three times we are applying it. So k1 k2 k3, three keys will be there of size 56, 56 and 56 bit, total goes raised to 168 bit, right? Or 112 bits. There is a possibility of taking 112 bits also, right? So here k1 and k3 you can take same bit, right? Total three keys are there, total three keys we are taking. Triple DES is there, but means DES algorithm three times, right? So this is also is an example of symmetric key, right? As it is also is in symmetric key, then same key you can take for the encryption, right? So any k1 and k3 bit you can take that key same bit. Okay, so here 56 56 it can be an 112 bit also bit, right? Either you can take all three keys different, or you can take that k1 and k3 as same key bit, then size will be that 112 bit. But 112 bit also is an we can say that good size of keyword, right? Some better size of that keyword, right? Even if it is in 112 bits, there is, right, 800 days they will take it. Means there is an significant improvement in that security bit from 400 days to it raised to 800 days, right? So uh, that's why they have introduced the concept of DES, right? You can see the diagram of this DES, triple DES, right? Same DES algorithm is there, right? 3 times we are repeating. Okay, so first P we are taking as in plain text, right? P we are taking as plain text. One before going to this diagram, right? One thing I want to inform you that this algorithm, either you take the DES or you take that triple DES, right? Mostly it is used in financial transactions. Mostly it is used by that uh, uh, right, secure electronics transactions, right? Or it is used for that payments purpose, right? Banking purpose, payments purpose, financially transaction purpose, right? Wherever the things are there for.
Hello, hello.
Yes, sir.
Yes, yes. Connection lost. Reconnecting. So, uh, right, the application of this DES algorithm, you can say that mostly it is used in that financial transactions, right? Or for that banking purpose, you can use this DES algorithm. Okay. So here to improve that what we can say that security or to improve that strength of this DES algorithm, right? They have introduced the concept of triple DES, right? So here two departments are there. One is that FIPS or NIST, right? So these two departments will approve, right? Right? Or they will announce that implementation of certain algorithm. Okay. So okay, so here very first that our input is plain text, right? Here plain text size will remain same as it is in DES algorithm. So plain text size will remain same as it is 64 bit, and key size also will remain same as 56 bit key, right? So plain text, what that plain text, right? Same plain text we will apply for the three stages. Same plain text we will apply for the three stages, right? So when they are performing some operations, they need the keyword, but the key is getting divided into the three parts: K1, K2, and K3, right? Here in this figure also you can see that we have taken K1 and K3 as same, K1 and K1. Only that second key is different. Only that second key is different. Means what? In this figure, they are using the key sizes 112, not 168. Right? It is your choice. You want to take that 168 bit key or it is a 112 bit key. Right? So first of all, this 56 bit key is much enough for us, right? But as that computational devices got improved, right? That's why we want some significant changes in the key also. So directly we have doubled it, right? From 156 now it is become as 112, right? So that is enough for us. Okay. So that's why here they are taking the two keys, but K1 and K3 are same. Okay. So same text size will remain same. That same 64-bit text, right, will passes through in all three stages, right? So here in first when you have taken the 64-bit plain text, right, along with the key K1, you have applied the DES algorithm for encryption purpose. For encryption purpose, okay. So first here A is there. A means you will get the right. A means here you will get that cipher text. first ciphertext. A is nothing but first ciphertext, or you can say that C1, or you can say that C1. Okay, so plain text is their P. You have applied some des encryption algorithm along with the K1, right? Then your encryption des algorithm will get applied, and you will get one output as A, right? That A is nothing but first ciphertext. First ciphertext. Again, that ciphertext we are taking as an input to the second stages, right? Second stage, that is called as a decryption. Triple dash means first we are encrypting, second we are decrypting, and third again we are encrypting by using the DES algorithm. That is called as a triple DES. So first we are applying DES algorithm for encryption, second we are applying DES algorithm for decryption, third we are applying the DES algorithm for encryptions also, right? As a single process, not three different process. You will give input as an P and you will get output as an C. But inside that process, right, inside that process, right, these three things happen. First, your plain text will get encrypted, then again it will get decrypted. After decryption, again you will not get your original plain text. Right, here key is different. K2 you are taking, right? So it will generate B, right? It is not generating the P. It will generate the P means another ciphertext, right? So here first, right? First plain text is the P. That plain text you are encrypting, right? Will get encrypted with the help of the key K1, right? And it will produce the first ciphertext, first unreadable text A. That A you are giving as input to the another process, that is decryption process, with the help of the key K2, right? So ciphertext is there and you are doing the decryption, right? So it should generate the plain text, but no, right? Here keys got changed, so another different type of ciphertext it will produce, that is B, right? So two times of cipher is again in third stage, again you are encrypting the second cipher to produce that C3, right? C3, and that C3 is our final ciphertext. C3 is our final ciphertext. So here in second stage, key is getting changed, right? Key is getting changed. That's why it is not decrypting that ciphertext to the plain text, right? Another cipher you will get, okay? And stage 3, right, data will key will remain same but data will get changed, right? Data will remain same, right? But key will remain same but data will get changed, right? So earlier encryption was different. In between that, K2 have decrypted your data second time also. K2 have decrypted your data second time also, right? So another second form you got, then second form it goes to that another third form, right? Third form, okay? So then it will produce the ciphertext, then it will produce the ciphertext, then this ciphertext you can use for this transmission, right? So in this way we can right, do the secure electronics transaction, right? So this is, or triple this is very much suitable or very much accepted in financial transactions or by the banking people, right? Only thing, this what is the difference between here DES and triple DES is they have increased that key size. So in DES the key size is 56 bit, and in triple DES that name itself right, indicate, or that name itself suggests that triple means three times you are using that DES. Three times means 356 bit key, right? So it can be that 168 bit key, but 168 bit key means maintaining every time it is somewhat difficult. Security will be high, right? But maintaining will be that difficult. That's why they have given one option that you can reduce that 168 bit key to 112 bit also. Your wish, you can use 112 bit or you can use that 168 bit, right? Triple DES means DES encryption, DES encryption, DES encryption. It should happen like this, but not. right? What they are doing, the first stage they are encrypting, second stage they are decrypting, and third stage again they are encrypting, right? So only the key is getting changed. Key is getting changed. Okay. So first you are encrypting, right? Second you are decrypting with some different key. Then third one again you are encrypting with some first key or some different key bit. Okay. So you will get that ciphertext. So that is this encryption in triple text. Same thing you can decrypt also. Same thing you can decrypt also, right? For decryption, below that second diagram is there. First input you will take as a ciphertext, right? With the help of this key K1, you will decrypt it. Simply the reverse of this encryption, right? So decryption you are doing, then it will produce that PU, right? So here you see that above diagram. At last stage we have done that encryption. So opposite of encryption, we will do first decryption. In second, you have did the decryption. That's why in second here we are doing encryption, right? And again in that first you are did that encryption. So here reverse we are doing the decryption, right? By using that same key. By using that same key for encryption and decryption, we are using that same key, right? So this is the decryption process. Okay. So here in this DES algorithm, use three times. K1 is used to encrypt that message P, resulting in that some ciphertext C1, right? And this K2 is used to decrypt that C1, resulting in that C2 ciphertext. So right, why we are using here C1 and C2, that decryption means you should not think that always we will get that same decryption, right? Same ciphertext we are getting. If the K is changing, right, key value is getting changing means you will get that different ciphertext. So here in first stage we are encrypting, right, plain text P by using that key K1. Then it will produce that ciphertext C1. Then that ciphertext C1 will be used as input in the second stage, that is decryption. So C1 is will get decrypted, right? C1 will get decrypted, right? If the C1 is getting decrypted means you will think that it should produce that P. It should produce that P, right? But not. Why means here we are changing that key K2, changing the key to K2. So key is changing means obviously that output will not be same. Output will be somewhat different. That's why that output we have given as a C2, another ciphertext. Then in third stage, the C2 will become as a plain text, right? As a plain text input we are giving to the third stage. Again, it will get encrypted and will produce that final ciphertext, that is C3. Then you will take this C3 and forward this C3 for transmission purpose, or this you will forward this C3 to the receiver. Okay. So like this, three stages we are performing the test. So this is happening inside this triple dash algorithm. Here you can see, right? Only you are giving that plain text and you are getting the ciphertext. But inside these algorithms, right, this algorithm will get applied for three times. First for dash algorithm for encryption. In second stage, same dash algorithm but decryption process. And in the third stage, dash algorithm, right? Then again it will encrypt it, right? That encrypted text will be your ciphertext, right? And at each stages, that key will get changed, right? Key will get changed at key 1, key 2, key 3, or key 1, key 2. Again for third stage you can get that key 1, right? Three stages. Okay. So this is your triple dash algorithm. Triple dash means simply dash algorithm is applied three times. Dash algorithm is applied three times. Okay. With the help of the dash algorithm is applied three times. right, with the help of the three different keys. Three different keys. Okay, so here you can write that same thing in equation. Same thing you can write in equation. One second. So this triple dash you can represent mathematically in this red color equation, right? But the thing is here that we need to start this equation on from right hand side, right? We are starting this equation from right hand side. So on right hand side you see that very first P is the plain text. P is the plain text, right? So we are applying encryption algorithm, right? We are applying encryption algorithm E, right, on that plain text P with the help of the key K1, with the help of the key K1, right? K1 comma P, K1 comma P, that indicates that, right, we are doing encryption. We are doing that encryption on this plain text P with the help of the key K1. Then you will get your plain text will get encrypted, right, and it will produce some output. Encrypted output means ciphertext. It will use C1. Then that C1 again you see that what all that output you are getting after applying that encryption algorithm on the plain text with the help of the key K1. It will act as a, right, plain text for this key K2. It will act as a plain text. It will act as a plain text, right, for the key K2, right? Then what we are doing in that second stage, decrypting we are doing. What you are decrypting, right, the output what we got from this encryption process, right, with the help of the key K2, right? So again it will produce some output. Again it will generate some output, that is decrypted text. That is decrypted text, right? But here the key is different. So decryption means it will not generate that P as it is. Again it will not generate the P root. Why it is not generating? Decryption means we are encrypting the P, so we will get that ciphertext. If you are decrypting that ciphertext, again you should get that P, but you will not get the same key. Why? Means here key is different. Here key is different. Okay, so K2 we are applying here. So again it will produce some different output, right? That output we are again applying for the K3 for that encryption process, right? Then you will get that final ciphertext, that is C, right? That is C, right? So you need to remember this diagram, and as well as you need to remember this equation, right? Below this diagram you need to write this equation, right, starting from the right hand side. Starting from the right hand side. Okay, so here that life of this test is from 1985 to 2017 only, right? In 2017 they have discarded, or they have removed, or they have declared that expired soft algorithm. Right now they are not using this DES algorithm. Right? Why? Means more powerful algorithms came into that market than this DES and triple DES. Okay, so in last we have used in 2017, from 1985, that is to 2000, means that is 15 years. This is 17 years. Total 32 years it was there in the market, right, for financial transaction, right? who will decide this one means here you can see that one department is there with FIPS, right? One department you can see on that screen, FIPS, right? Federal Information Processing Standards, right? Such committees, such departments are there. They will decide that one. Okay. Uh, so same opposite of this encryption is that here second red color diagram, red color equation is for decryption, right? So that decryption also you can read from that right hand side. First you will take that final ciphertext, right, and it will decrypt it with the help of that key K3 reverse. Decryption means reverse. Okay, so here we have taken that K3 at last. So here we are taking K3 as first. Here we have taken K1 as a first. Here we are taking K1 as a last. Okay, so here then decryption to ciphertext means it will generate the plain text. That plain text again we are encrypting with the help of this key K2. Okay, then again it will produce, right, some output. That output will act as an input to that decryption algorithm. With the help of the key K1 it will decrypt it and produce the plain text. Okay. So here is the two diagrams are there for encryption and decryption, and you can enclose these three things: EDE, encryption, decryption, and again encryption, into a rectangular box. Why means these three are one single process. It is happening inside that algorithm. They are not individual. Okay, so you give plain text, you will get the ciphertext. Okay, so we need the two or three different keys, right, to provide at different stages, okay. So this one is was that, right, triple dash. Simple thing is there, right? Only that dash algorithm we are applying three times, right? Nothing else, right? Dash algorithm we are applying three times, right? If you are applying the dash algorithm three times means obviously the key size will get increased, get multiplied by 3. 3 times means 56, 56, 56, 168 bit, right? But they are giving you a choice that in place of taking that 56, right, 168 bit, you can take that 112 bit. So why and how means you are doing 2 times encryption in triple dash and 1 time decryption, right? So why can't you take that same key for the 2 times encryption, right? Why can't you take that same key for 2 times encryption and different key for 1 time decryption, right? And it is also working fine. So that's why 56 plus 56, right, it is 112. So 112 bit size key also you can take. Okay, so here just now I have shown you the differences, right? Only these differences are there to improve the security, right? Next is AES is there. In next class we will see that AES algorithm, right? AES there, if time permits, more symmetric encryption algorithms are there, right? Then we will see RC5 is there, IDI is there, right? We will see with other sections how much algorithm they are covering. These many algorithm we will also cover. Okay, but these are mandatory. DES is there in syllabus, triple DES is there in syllabus, right? AE is there in syllabus, RC5 is there in syllabus. That we can take, that we will see. Okay, so here once again, right, DES is work only for, we can say that 10 years, right, from 1975 to 1985. Then they feel some improvements in that DES algorithm. So what improvements they did that, right? So that single DES they have converted into that triple DES. Means that same DES algorithm you can apply 3 times, right, on your plain text size. So 3 times means the encryption they are not doing, right? They are doing that first encryption, then they are doing the decryption, then again they are doing that encryption with 2 or 3 different keys. Okay. So from 1975 to 1985, the DES have worked very well. Then from 1985 to this 2017, they have used the triple DES, right? But in 2017, right, so many other algorithms. Means like you can take that example of AES is here, right? Whose key size is 128-bit, 192-bit, or you can even take that key size as 256-bit. So like that, high secure algorithms are available in the market. That's why they have said goodbye Tata to this DES and triple DES. Last use in 2017, right? So AES also is available at the time of DES, but they have recommended DES only. Okay, but after that one AES also right, improved that key size to 192 or the 256 key, right? Means that security is getting security got increased, right? You say here you can see that if you are using that 5 into 10 power of 21 years, it will take that to decrypt. Nobody will wait for these many years, right? Entire scenario will get changed. Even if you are able to decrypt the text after this year, that the data will not be useful to you, right? Data what all that you are cracking or hacking, right? If it is in, right, 1 month, 1 year, that things are there, but the password will remain same, right? Or the person will remain alive, right? Many things will be there. But here 10 power of 5 into 10 power of 21 years means total scenario will get changed, right? Neither bank will be there, neither person will be there, nothing will be there, and who is decrypting that also, he will not be there. Okay, so what is the use of trying for such data? Okay, so that's why we that name itself it is given as an advanced encryption standard, AES. Okay, so presently we are not using DES or triple DES in banking transaction. If small business peoples are there, right, they whoever is want that less security, or for them this DES algorithm is well suited, might be these people using that one, right? But that standard banking services, right, or transaction services, they are not recommending to you go for this triple test. Okay, so with this we will stop here. Okay, next class we will see that advanced encryption standard. Okay, thank you. You can start posting your own numbers. Only thing short, remember that triple DES is nothing but DES algorithm 3 times we are repeating. That's all, right? And the 2 mathematical equation I have shown you, right? I will share with you that okay, that diagram, that equation, and some explanation. These 3 things are enough for this triple DES. But for the DES, you need to remember this what is happening in that round, right? Entire that block diagram and that actual round diagrams, that you need to remember it, right? They may ask in examination. But here for the triple DES, no specific diagram is there. Only DES algorithm we are repeating 3 times. Encryption, decryption, again we are doing the encryption, right? 56-bit key, 56-bit key, 56-bit key, right? So 3 times DES will get repeated, and finally it will produce the cipher text. Okay, so encryption and decryption, the two diagrams are there. Encryption and decryption, two equations are there, and some explanation, right? Why it's got replaced, right? Why desk got replaced with that triple desk, in which year, who invented, right? Where invented? Again, it is a product of IBM only. Again, that IBM people only have developed this desk and triple desk, both algorithms. This diagram, simple diagram is there. E for encryption, D for decryption, again E for encryption, right? K1 is there for encryption, K2 is there for decryption, again K1 is there for encryption, right? So here on that left hand side, P is there to indicate that plain text, right? And C is there to indicate that ciphertext, right? And A and B are the two different ciphertexts are there. So in place of A, you can use that C1. In place of B, you can use that C2, right? It will be more clear than A and B. C1 and C2 means C1 is producing a first ciphertext. C2 is producing that second ciphertext, and C1 and C2 are not equal. Then finally we are getting C, our main actual ciphertext. That that we are applying to that decryption process. So first input will be that ciphertext, right? So we are doing that decryption first with the help of the K1, then encryption with the help of the K2, right? And finally decryption with the help of the K1, right? It will produce that plain text. Okay, so this is the simple diagram is there that you need to remember first in triple disk, right? And these two equations and this, right? This same diagram, either this one or that one, anything. Then these two equations, right? How you can write that process mathematically, right? C is equals to E of K3, comma D of K2, comma E of K1, comma P1, right? Open the brackets and close the brackets accordingly, right? So first K1 comma P encrypting, then decrypt the process with K2, then again encrypt the process with K3. Okay, so this is mathematical representation of that encryption and decryption. Okay, two things. ISMA P0 26 38 42 K5 L1. M8. Have you posted your roll numbers? Forty-two K5 L1. जी बेटा